My name is Anthony Nathaniel, and today I'll be continuing the second episode of our topic on sets. So, in the previous episode, I probably told you to watch out for the second episode, right? So, I'm glad you're watching out. So, and if you have not seen the previous episode, the first episode of sets, you can go over and check it because though I will still do a little bit of revision of most of the concepts I introduced. So, here we go. Now, my revision goes thus. In the first video of our episode on sets, that's in the previous video, we talked about a set being a collection of things, and those collections, they are well defined. So, and those things, they are also known as the elements. We call them elements in mathematics. Those are the elements of the set. Then we can describe a set by listing its elements, or we can just describe it by stating one general property that governs all its elements. So you can also use a capital letter to stand for a set, and use curly brackets to contain the elements. And the set can also be represented by Venn diagrams. So Venn diagrams are basically enclosed shapes, mostly rectangles and circles, that are used to show sets and the relationships between them. That is simply what the Venn diagram is. Now, two sets are equal if they contain the same elements, and order and repetition are not important. So that's what I talked about in the previous video. That's what I stressed upon. Then I also stressed upon the null set or empty set that has no members, and the two ways of representing a null and an empty set. Then we'll talk about the universal set being the set of all objects under discussion or consideration. Next, we also talk about an infinite set as a never-ending set, and that you cannot list all the elements of. For example, I gave an example that that the set of all positive numbers is an infinite set, but the set containing only letters A, B, and C are finite sets. Next, we have languages used to represent sets, and then that is what we'll be building on in this second and last episode of sets. So now in this episode, we're starting with let's first give an example to refresh our memories of the previous episode. In the previous episode, we talked about the universal set. Now, given that in the universal set is the set of formula, assuming this is the universal set within curly brackets, it's set of F, O, R, M, U, L, A. Now this set contains these elements: element F, element O, element R, element M, element U, element L, and element A. Now the next set is a subset of that universal set, and the set A is a subset which contains elements F, R, A, M, and E. Then lastly, we also have element B, which contains we have set B, which contains elements R, element U, element L, and element E. Now in this question, we are asked to draw a Venn diagram showing the information above. So I have to show the universal set A and set B, and then we are also asked to find the number of elements in the union of sets A and B. Now the first set we will draw is universal set, which is a rectangular set, typically a rectangle, though you can see it in other shapes and forms. So this is a universal set. It has kind of like a curly form at the apex of the lettering. Then now this A and B, they are obviously elements. They are obviously subsets of the universal set. So this A is a set of frame. So we are going to draw it like this. This will be our set A. It has F, R, A, M, E. And then our set B. Before we draw our set B, we'll have to ask ourselves, are there any elements that are shared by A and B? For example, A has F. Is F here? No. Is R here? R is here, right? That is called the intersection of A and B. So in the previous video, I explained that an intersection is an intersection of two sets is a third set that contains the elements that are in both of the first two sets. So now for this set A and set B, we've listed the fact that set R is shared by both set A and set B, right? That is the element, and it forms the intersection of set A and set B. So I'll circle it here. It's an intersection. Then which other element is shared by both set A and set B? You can see that is element A is in A, right? But element A is not in B. Element M is in set A, but element M is not in set B. Then element E is in set A and it's also in set B. So that that is kind of the intersection. So that will be the element of the intersection. Now if there are elements that are shared by both sets, or rather if you can find elements that will form the intersection set, then you will let these two circles to cross each other, they will overlap. So this will be our set A and this will be our set B. Now in the middle, in that overlap, we will put those two intersections. That will be R and E. R and E. So that will form the overlap of the two sets. Now any other thing will be the elements that do not that do not um that do not appear in both. So like the F and A and M and E. So that will be, sorry, F and A and M. E is already an intersection, so we'll put AF, A and M. Then for the set B we have U and L, U and L. So those are the elements of A and B. This is the element in A only, this is the element in B only, and this is the element in the intersection of A and B. Now you can see that there are three distinct regions. Now these distinct regions, they have their names. Now this is a representation of the data. This data we've represented it in a Venn diagram. And let's talk about the next part of the question. What is the cardinality of A union B? So the question says, what is N of open bracket A union B? So what this is asking is that how many elements are in the sets that consists the union of A and B. The union of two sets is a set that contains both the elements in A and B. So the union will be everything from A to B. That will be F, M, A, E, R, U, and N. That will be 1, 2, 3, 4, 5, 6, 7. So our cardinality of A union B is 7. Now let's talk about the distinct regions. This A union B is the region that contains both A and B. That is, when you shade the two circles together, you will get the region A union B. But when you shade only the region of A without this intersection region, is called region A intersection B complement. So what that means is that this region contains only the elements in A. So it's denoted A intersection B complement. That's the intersection of the set A with the elements that are not in B. Then B only is represented as B intersection A complement. So that means the intersection of B with the elements with the set A with the elements that are not in set A. That is B only. Then the intersection of A and B is simply known as A intersection B. So that is the approach to the question. Now next, let's talk about the different symbols. Now when you are talking about a set, you use capital letters for the name of the set. You can also represent this an empty set as a circle with a strike through. Just strike through the set. Yes, that's an empty set. And then your strike through should be kind of slanted or kind of diagonal. Next we have the universal set. The universal set is represented as an E. You represent it as E or as a U. So a U with a curl at the at one of the top ends. So and then we have when you want to represent that the fact that an element is a member of another set, you represent it with the letter E. So when you want to represent that an element is not a member of a set, you represent it with the same letter E, but with a strike through. So you strike it through to mean that it's not an element of the set in consideration. Then next we have when you want to represent that a set is a subset of another set, you use the letter C. Then if you want to show that it's not a set, it's not a subset, you use the same letter C but you cross the letter C to show that it is not a subset of that set. Then next, if you want to show that a set contains another set, we use an inverted C. So you turn the C to the left. Then if you want to show that it does not contain another set, you use the same inverted C but with a strike through. So those are the basic different notations used to represent sets. And next we're talking about the set builder notation. So what questions do we need to understand in sets? So let me talk about that first. Now our set builder notation, I will give an example. List the members of the set. Let me write the set down. List the member of the set. This is the set. These are not curly brackets, these are just rectangular brackets. Then y such that y colon 1 is lesser than y is lesser than or equals to 6, comma, y is an element of natural numbers. Now your natural numbers are your numbers that you naturally use in counting, like your 1 to 3. They are just like your positive numbers. Now this is a set builder notation. We are building a set from these rules. So we have set a rule that rules that the elements of this set will be y, such that y, 1 will be lesser than y. That means y will be greater. That means y will be greater than 1, but y will be lesser than or equals to 6. So what that means is y is greater than 1 but lesser than or equals to 6. So if that means y can't be 1 but y can be 2. So we can list the set as this. Y can't be 1, it can be 2, it can be 3, it can be 4, it can be 5, and it can be 6, because it said y is lesser than or equal to 6. So this is how we build a set from set builder notation. You often see this in questions, but don't be afraid. Most of the time you just need to understand the regions being considered. Now let's talk about practical application of sets. Now this practical application will be solving a question on sets. So this question says 50 students were asked what they did last night. 16 said they read a book, 41 said they watched television, 7 said they did neither. How many students did both? Now they said 50 students, right? 50 students is the total number of students. So that will be our universal set. So our universal set rectangular would be 50 students. Now they said 16 said they read a book and 41 said they watched television. Now 7 said they did neither. Now 16 that read a book will be the elements of a set A. Let's call that the people that read the book, let them be members of the set A, and the set A will have a cardinality of 16 because 16 students read the book. Now the next set are the ones that watch television. There are 41, so that means the cardinality of the next set will be 41. That will be N. Let's call the set of those who watch television B. The cardinality of set B will be 41. So because 41 students said they watched television. Now set 7 said they did neither. Now which set did neither? Now that set that did neither is the complement of the set that did both, and that set that did both is the union. So the complement of that union is simply the number of elements in A union B, then close your bracket, put a complement. So that is the ones that did neither. So this is a region. The region that is outside your union is you make use of a complement above it. So that will be 7. Now let's delve into the matter and draw the circles. Let's represent this as A. This set A. Yes. Then we also have set B. This will be set B. So set A is the set of students who said they read a book, and set B is the set of students who said they watched television, and 7 said they did neither. Now this 7 will be outside, so it will still be in the universal set because they are still part of the students, but they are not part of those who watch television or read a book. So they are outside these two circles, but still inside the universal set. But in this A, we have 16 in the A, and we have 41 in B. Now there's a region, we don't know how many students are in the middle region. Let's call it X, because it's an unknown we don't know, right? In mathematics, you often refer to unknowns as X. You make use of any alphabet of your choice. In the first episode of this video of this course, I said my favorite alphabet is X, so I'm used to it. So you can adopt any letter. You can use mix of A, mix of B, and so on and so forth. Now if a part of A is X and the total of A is 16, so that means the remaining portion of A will be 16 minus X. That's basically rules of addition. So now if you take X out of 41, if X out of 41 is here, then the remaining will be 41 minus X. That's basic rules of addition, because when you add them together you still get 41. So this region plus the middle region will give us 41. 41 minus X plus X, that's 41. Then this one 16 minus X plus X will still give us 16. So this does not disobey any laws of the question. So we still have 16 and 41 as our original total members of those who read and those who watched television. Now next, the question says, find how many did both. Now in this example, the number that did both is they are the elements of the set, this set A intersection B. So an intersection set is a set that is in the middle of two sets in consideration. Now this intersection set is X. So the number of elements in the intersection set will be X. That's X. So we are looking for X. Now there's one thing in set, that in a universal set, the sum of every element in the set and the elements in the complement of that set will give us the universal set. So that means the sum of elements that is in the union and the elements outside the union will give us the universal set. So that means is the number of elements in A union B plus the number of elements in the complement of A union B. That means A union B, close your brackets and put a small one symbol. That's complement. So when you add them, it will give you the number of elements in the universal set, and the universal set is the set containing all the students in consideration, and the set that is 50 students were asked, right? That's 50 students. Now in this universal set, the universal set consists of those that read only, that is 60 minus X, and that is represented as A union B, A intersection B complement. That's the number of A intersection B complement. Then we have next the number that read and watched television. That will be number of A intersection B. Then lastly, we have the number that watched television but did not read. That will be number of B intersection A complement. Then lastly, plus the number that did neither. That will be number of A union B complements. So when we sum everything, that will give us 50. So in the first region, we have 16 minus X plus 41 minus X plus 7 will give us 50. When you evaluate this, at the end of the day, you will get minus X plus X will cancel each other, because X minus X is 0. Now we'll be left with X. So let's move X to the other side. That will be 50 plus X. Let's move 50 to the left hand side to meet the numbers. That will be 16 plus 41. That's 57. 57 plus 7. That's 64. Yes, 64. Then when we move 50 to the opposite side, that becomes negative 50 minus 50 will be equals to X. That means 64 minus 50 is 14. 14 will be equals to X. So we've successfully answered the question, which says how many did both. That means the number of students that did both will be 14, because this 14 is in the middle region, and the middle region is the intersection, and it also represents the number of students that did both. Now we've come a long way, right? And I appreciate you all for putting so much effort in watching this video up to this time, and I will say that you should put more effort in knowing this subject, because of one constraint or the other, I might not be able to move on with this topic. But there are more aspects of it I might want to cover, but you might also have to cover parts with three diagrams. So in such a diagram, you'll be using three different sets, and then okay, let me take that in stride. Let's do that. So I don't want to just describe things, so I prefer showing you directly. So let's do that live and direct, so that we would call this a complete analysis of sets. In a survey, this is the next question, and this question we are dealing with three different sets of three different sets in consideration. That is three different subsets of a universal set. So in a survey of students, it was discovered that 76 liked history. So let the number of students in history, in the set of history, let's call it N of H. That was 76. Then next, they said 98 liked geography. Let's call the number of students in the set of geography. That would be 98. Then lastly, they said and 87 liked mathematics. That means let's call the number of students in the set of mathematics NM. That's 87. Now next we have 15 liked all the three subjects. Now whenever you are talking about people who liked all the three subjects, that will be the union of, that will be the intersection of everything. So that will be intersection, the number of the intersection H intersection G intersection M. That will be 15. So next we have 39 liked history and geography. So that means the number of students in the intersection of history and geography, that will be history intersection geography. But because there are three, the third set that is not included will be complemented. That will be intersection. That third set will be what? Mathematics. So we'll complement mathematics. That will be N open bracket H intersection G intersection M complements. That means the number of students that like history and geography only. So that mathematics with a complement means that mathematics is excluded. Now next we have 48 likes geography and mathematics. So for this one, geography and mathematics will be G intersection M, then intersection history complement, because complement is not, because history is not included. Next we have and 45 likes none of the subjects. Wow, those are very insouciant students. Now this 45, they will be represented by the number of A union B, not A anymore, H union G union M. So one will take the complement of every union. That would be the set of those that are completely insouciant. They do not like any subject. Now they said show this information on a diagram. That's the question. That's the first part of the question. And the second part said how many students took part in the survey. Now we are looking for the total number of students in the universal set. Now let's delve into this. Now let me draw it. This will be the universal set. Let's denote this time by E so as to make it balanced. Now let this be the set H. Let this be the set G of geography. Let this be the set M of mathematics. So the number of elements in this circle of history, in this circle of history is 76. Number of students in this circle of geography is 98. Number of students in this circle of mathematics is 87. So next we have so they said 98 likes geography and 87 likes mathematics, and 15 likes all the three subjects. Let's put that now in this little section. Let me magnify this. In this little section that involves all the three cycles, that's this, we will write 15 because this is the intersection of all the subject. That will be 15 here in this small region. That will be 15. So we have 15 there. Then next we have 98 likes geography. 39 likes history and geography. So 39 likes history and geography. So that means this remaining portion for history will be that 39 minus 15. So because there is a sum of 39 and 15. So 39 minus 15. Now having bolded that, let's continue from where we stop. This is 15 here, intersection here, and then the number of students that liked 39 liked history and geography. That means the intersection of the history and the geography will be 39. That means this whole section here is 39, right? But then we have 15 out of 39, so we are going to subtract 15 out of 39 to get the second part. That will be 39 minus 15. That will be 24. Next we have they said 37 liked history and mathematics. So that means the intersection of history and mathematics, that is this whole section here, will be 37. But then we have 15 out of that 37. So we're going to subtract 15 from 37 to get from this for this second empty space. That will be 15. That will be 37 minus 15. That will be 22. Then lastly we have and 48 likes geography and mathematics. So that means the intersection of So that means the intersection of geography and mathematics is 15. Everything here is 15, right? That means we are going to subtract 15 from 48 to get this region here. That will be 48 minus 15. That will be 33. Now finally, we need to calculate these empty spaces. So, but we know that everything here, year plus year plus year plus year, will give us the entire history, right? It will give us 76. So now, in order to get this section, we are going to subtract 22 from 76. We subtract 15 and we subtract 24. So 76 minus 22 minus 15 minus 24. That will be 15. So there's 15 history only. Then next we have for the mathematics only, we will need to subtract. For mathematics was 87, right? So we're going to subtract 87. Let me make this visible. So we're going to subtract 87. We're going to subtract 33, 15, and 24 from 87. That will be 87 minus 33 minus 15 minus 24. That will give us 15 at the end of the day. That will be 15. 15 for geography only. Then for mathematics only, we are going to subtract from okay, sorry, I mean that was supposed to be for mathematics. So 87 minus 22 minus 33 minus 15. That would be for mathematics only. That's 17. 17 here, right here. Then for geography only, if everything is 98, then to get this remaining part, we need to subtract 33, subtract 15, and subtract 24 from 98 to get the part of the student that did only liked only geography. That would be and geography entirely is 98, right? 98 minus 33 minus 15 minus 24. That would be 26. So everything is 26. Now at the end of the day, they now said 45 likes none of the subjects. Now those students that like none of the subject, they will be here. Those students that like none of the subject, they will be outside this region. We could represent them, and that will be 45. They did not like any of the subjects. So now at the end of the day, we have shown this information. This is the complete representation of the information on a Venn diagram. And the second part of the question said, how many students took part in the survey? So now the student that took part in the survey will be adding everything in every section. That is, we'll be adding 45 to 17, yeah, to 33, to 15, to 22, to 24, to 26, to 15. So when we add everything together, we'll get the total in the universal set. So let me add that with my calculator. 45 plus 17 plus 22 plus 33 plus 15 plus 26 plus 24 plus 15. That will give us 197. That will be 197. Right? Well. So much. Now that was it on calculation using three different sets in three different subsets in a universal set. I know it got messy because of the limited space and because of it might not have been clear to you, but I hope you've been able to understand the basic postulates and the basic basis of sets. And with this, I'm going to draw our sets topic to a close, and next we'll move into a new topic in mathematics. So see you in the next episode.